Hello everyone and welcome to my new video. And today we're gonna solve some problems on Leetcode. So let's just start. The first problem is difference between ones and zeros in row and column. It sounds kind of difficult, but I mean it's labeled medium. I don't know if it's actually hard. So you are given an m by n binary matrix, and we need to create a difference matrix with the following procedure. So the number of ones in the ith row is ones row I. The number of ones in the jth column is ones col j. Okay, and let the number of zeros in the ith row be zeros row I. And let the number of zeros in the jth column be zeros col j. And then diff ij is equal to ones row plus ones column minus zeros row minus zeros column. For example, I equals 0 and j equals 1. No, I equals 0 and j equals 1. So then we're on this square right here, and one's row is 2 because there are two ones. One's column is 1, so 3 minus zero's row is 0, and zero's column is 2, so 3 minus 3 is equal to 0. Okay, now for this one, one's row is 2, one's column is 3, so 2 plus 3 is 5. Zero's row is 1, zero's column is 0, so 5 minus 0 is 4. So here's a 4. Oh, the explanation looks really hard, but I mean the problem is actually not that hard because look, one's row plus zero's row is equal to n. Wait, m by n. Wait. Yeah, it's n. So n is the width, and m is the height. Yes. And once in that row plus zeros in that same row is equal to the size of that row. So we can write zeros row is equal to n. What did I just do? N minus one's row. And then same for the column. Zeros column is equal to n minus one's column. And now we can write this expression as one's row plus one's column minus n minus one's row minus n minus one's column. And now if we open the brackets, then we get one's row plus one's column minus n plus one's row minus n plus one's column, which equals to 2 times one's row plus 2 times one's column minus 2n or maybe let's write 2 times n. This is how we simplify this complex expression. And now, we just need to calculate one's row and one's column for every row and column. Yeah, and this is not as difficult to do. So, why am I writing it in JavaScript? So Python, what is this? Python 3? No, this is just better. I have no idea why the syntax changed in Leetcode Python, but okay. We just iterate for row in grid. No, first we need to define the lists with variables one's row and one's column. So one's rows will be an empty array, and for row in grid, so one's row is equal to 0 first, but then we iterate the row. So for number in row, if this number is equal to a 1, if this number is if this number is equal to a 1, then we increment one's row. So one's row plus equal 1. And at the end, one's rows dot append one's row. So basically we iterate every row, and if it's a 1, we add 1 to the one's row variable, and then we add it to the list one's rows. Now the same for one's columns. One's columns is equal to a list. And now, so first it would be better to maybe compute m and n. So m is the height, right? So m is equal to length of grid, and n is equal to length of the first row of the grid 0. Let's comment that out. And now we iterate for column in range n, because n is the width. There are n columns, and we iterate the range n. And then one's call is equal to one's call is equal to 0 again, and then for number in grid col. So grid col is basically the column that we're in, and we iterate for every number in that column. And again, if it's a 1, we add 1 to one's col, and we append one's col to one's, no, we append one's call to one's calls. Maybe it would be better like this. Wait, why can't I? Oh, I can't change the font. Or can I? Oh, I actually can. Let's make it 15. Yes, this is better. Yeah, so we calculated one's rows and one's columns. Now what? So now we create a matrix diff. Oh, and oh, I only understood now that I actually messed up this calculation. So I was right that one's row plus one's, no, plus 0 zeros row is equal to n, but one's column plus zeros column is equal to not n but m. So if we rewrite it as we did, it would be not n minus 1's column, but m minus 1's column. And now, if we write one's row plus one's column minus zeros row minus zeros column, we replace zeros row by n minus 1's row, and we replace zeros column by m minus 1's column. And now if we remove the brackets like this, and we group the 1's row and 1's column, we don't have 1's row plus 1's column minus 2n, but instead we have minus n minus m. So that was my mistake, and I'm sorry for that. And also I'm sorry for wasting your time having to explain all of this. Okay, so we have the 1's rows and 1's columns. What should we do now? So we make a matrix difference matrix diff, and first it's an empty array, but we add some numbers there. So for row in grid for num in row. So for row in grid, div append an empty array, and for num in row, div -1 dot append 0. So this might look complicated at first, but for every row, we add a row to the matrix div, so we have the same amount of rows. And now for every number in row, we add a 0 to the current row. So, for example, when we are on the first row, we add a row to the difference, and that way this first row becomes the last row in difference at that current moment. And for every number, we add 0 to the last row in diff. So in this case, it's the first row. So we add 0, 0, 0. Then for the second row, we append a row again. And now this becomes the last one. We add 0, 0, 0. And that way, we just fill the matrix with zeros to later fill it with actual data. And now, we iterate for every once row and once column. So for row once row and enumerate once rows, for call once calls in enumerate once columns. So what we're doing here is for every row and for every column, we get the index of the row and the column, and the corresponding data of the once row and once column. Oh, I don't need an S here. Yes. And now, now we put the div row column is equal to 2 times once row plus 2 times once call minus n minus m. So what we're doing here is we're iterating through the grid, and for every value, we compute the value that we need to put in the difference matrix, and we put it to the corresponding coordinates. So this is the computation, and here we just put it into the matrix. And with that, we're basically just done. We just need to print the difference matrix. And that's about all. So let's run it on the test cases. And we get some error. List index out of range. Here, for number in grid column. Oh, it's because okay, so I got it. Here we're iterating for a column, and for example, on this matrix, the column is 2, so basically the third column. And now here I made a mistake because grid column is not a column in the grid, but a row. And Yeah, it's not a column in the grid, but a row. And the problem is that, for example, here there are only 2 rows, and we're calling the basically third row, which doesn't exist. So how do we fix that? How do we fix? How do we get the column in the grid that we iterate? So the solution is that we don't iterate the column at all. We just we don't get column. We don't iterate for the column and then for the number in the column, but we iterate for the column and the row in that column. So for row in for row in basically M, if the grid row column. So what we are doing here is first we choose a column. So for example, the first column, and then we iterate for a row, and we don't. And what I wanted to do first was to iterate for a number in that column and check that number. But we iterate for a row and check the number with the coordinates. So it's kind of complicated to explain. So I hope you understand it. So let's try to run it again. And let's see. Int object is not iterable. I'm stupid, I forgot range M. Will it work now? So we got a wrong answer. What is wrong in this case? And we just don't output anything. Why? Why don't we output anything? Why does the diff matrix stay empty? So maybe we'll... Oh, it's because we print the difference matrix, but we don't actually return it. Because again, I'm stupid. Return diff. Try to run it again. And now it works. So let's try to submit the code and check if our solution is correct. And yes, it worked. It worked. In runtime, I beat 19.80% of users with Python. I mean, it's not as impressive, but I beat 68.16% of users with Python with memory. I think that is because I think this is because I don't store both one's columns and one's rows. No, not because I don't store both one's rows and zero's rows. Because of the reworked formula. So yeah, our solution works, and we got an impressive score with memory. So yeah, that's about all for today. Thank you very much, and goodbye. See you in the next video.